Before we start using text files in our programs, let's make sure we know what they are. In this folder, there's a text file named listofthingstodo.txt, which pretty well describes my average day. I can open that file by right-clicking on it and choosing Open With. From the list of apps, I'll choose Notepad. All that's contained in that file are just characters. Nothing fancy, just characters. Make sure that you see that even the 1, 2, 3, 4, 5, and so on, they're not actual numbers, they're just characters. Now, let's try to do the same thing with a Word document. The one I'll choose is my additional reading document about the scanf function. All of the gibberish that you see is what's contained in that file. In fact, you can look all the way through this document and not find the actual words that I gave you. What's going on here? What you're seeing are the various codes for the different fonts, colors, pictures, and other formatting that Word lets me use to create a document. But what a Word document is definitely not is a text file. We'll do something similar with a PDF file. This time the file is for the first set of C questions. And again, all we see is gibberish that represents the format of a PDF file. And again, not a text file. So to recap, a text file contains only characters, no numbers, no formatting, no pictures, just characters. Does that sound familiar? Well, it should, because that describes the source code files that we've been writing. Here's one that I used to make a video about how to begin a C program. Let's see what it looks like when I open it with Notepad. Hey, all it's got is characters, which makes it a text file. I have a question for you. Does that mean you could write a source code file using Notepad? I'll let you think about that one. Text files are used to get input into our programs and to save output from our programs. Input and output. We've already done a bunch of that, so how is this going to be different? As it turns out, the code for using text files for input and output is remarkably similar to what we do when we use printf, scanf, and fgets. This video is part 1 of how to do all of that stuff. So let's see how it works in a program. If you're going to use text files in your program, make sure that you include the standard I/O library like I'm doing on line 9. Next, you're going to define a file variable that will let you get characters from a file or save characters to a file. And that's what I'm doing on line 13. I chose the name InFile for this variable because I'm going to use it to get input from a file. There's really nothing special about the name InFile. It's just what I usually use. For this example, I'm also going to define one integer on line 14. Now, just as though this were a paper file, we have to open the file before we can use it. So on line 16, I'll open a file named 4ints.txt. The file name goes inside double quotes, followed by a comma, followed by a letter indicating what the file will be used for. Here the letter R in double quotes means we're going to read input from that file. Here's a screenshot of what the file contains. If we were reading number input from the keyboard, we'd be using the scanf function. But since we're reading input from a file, we're going to use the F scanf function, where the first F stands for file. Look at the syntax here. The first argument is the name of my file variable. The second argument starts looking more like the regular old scanf function. It has the placeholder in double quotes, followed by the address of the variable where we want to store the input. Again, please see how similar this is to the scanf function. Now on line 18, I'm going to print the value that we read from the file. And when we run the program, our output displays that we read in the number 319 from the file. Here's a reminder of what that file contains. So what happened? Once the file was opened, we read in the first integer in the file. Here's the next example. The first thing I'll do is to declare another integer on line 14. Then I'll add a second fscanf function on line 18. And then I'll modify our output to show both numbers. So let's run it. Here, our output displays that we read in 319 and -7. In other words, the first two numbers in the file. Let's modify the program again. I'll define two more integers, add some extra fscanf functions, and modify how I want things to display. And when I run my program, it reads in all four numbers in the order that they are contained in the file, and then it displays them. So far, so good. What could go wrong? Well, for one thing, the file might not exist. On line 16 here, I'm misspelling the word for. Now, there's not a file on my hard drive by that name. Let's see what happens when I run the program now. Uh-oh, my program crashes because it can't locate the file I tried to open. This will happen to you. When it does, click the abort button and try and figure out what went wrong. Again, the error is the program can't find that file where it was looking. Keep that in mind for just a minute. So here's what I want you to do to protect your program from crashing when it can't find a file. First, on line 17, I'm going to put an if statement to see if the file actually opened. Here's what that looks like. Inside the curly braces, I'm going to put all the code that I want to execute, but only if the file opens correctly. And on line 24, I'll put an else that tells the user that some error occurred. Looking at my code, I see that lines 26 and 27 should be inside the curly braces too, so I'll move them there. Let's run the program with that bad file name and see what happens. Okay, this is good. It prints out the error message, no crash. Now, I'll go back and put the correct file name in my code. When I run it now, it does find the file, which makes the if statement true. So it reads in the four numbers and displays them on the screen. Anytime you open a file in a program, make sure you close it. That's what I'm doing on line 25. Also, look at lines 19, 20, 21, 22, and 25. The functions on all of those lines start with the letter F because they all deal with files. Remember when our program crashed? It was because it couldn't find a file with that name where it was looking. But where was it looking? The name of this program is CDemo. If you go to the folder where that project is located, you'll find the file. Why did I put it there? The answer is, unless you tell it otherwise, your program will assume the file is inside the same folder as the project. We can tell the program to look somewhere else, but let's save that for part 2 of these videos about text files. So, to use a text file in your program, what do we know so far? You need to include standard IOH. You need to define a file variable. You need to open the file. You need to check to make sure it opened with an error message in case it didn't. You need to use the file, then close it. See you in part 2.